This is simplifying a radical expression with two variables. So we want to simplify the square root of 12t to the 12th, w to the 11th. So what we want to do is break it into things that are perfect squares and not perfect squares. So for the 12, the different factors of 12, we could choose between 3 and 4 or 2 and 6. And we can't find the square root of 2 or the square root of 6. That wouldn't get us anywhere. So we'll go ahead and go with the 3 and 4 because we can find the square root of 4. It's 2. So we put the 4 in this first set of things that we can easily find the square root of, and 3 in the second set. And in a square root, the little index, it's really a little hidden 2. I'll stick it in there so you can see it. And with the 2, that means that all of the things that will be perfect squares are even exponents. So all 12 of the t to the 12th, those are going to simplify nicely with the square root. The w to the 11th, only 10 of those will simplify nicely because we're trying to get the highest even number we can with one of them left over. And the square root of 4 is just 2. And here you can just write t to the 6th. Or if you aren't quite sure where that's coming from, it's the exponent over the index. You don't have to write this step in there. I'm just putting it in there so you don't get lost. So then, when we go ahead and simplify it all the way, we get 2t to the 6th, w to the 5th, times the square root of what's left over is just the 3w.